Alright, welcome back everybody to Software Engineering 1. I am going to talk a little bit about architecture this week. We're going to go over kind of the project level stuff right now, and then in the next couple of videos we're going to talk more specifically about architectural patterns inside of the code itself. But so far in the class, what have we done? We talked for a long time about the process of creating software, the software lifecycle, all of the different nooks and crannies and phases that you have to go through in order to actually build a piece of software. Last week we talked a little bit about software organizations. How are they structured? How do they license software? How do software licenses work? And ultimately, how does that lead to profit for a software company? So everybody is in this class or in this degree program for a reason. Ultimately, that reason has to translate to something practical. Usually that practical thing is paying your rent. And so how do I get from generating a piece of code to paying my rent? All of that is kind of what we were focused on last week. So what we're going to talk about in this particular video is called Distributed Application Design. It's extremely popular right now and seems to be becoming even more and more popular. And we're going to talk about this popularity in context of some of the points that we've made previously in the class. So if you think about your experience as a computer science student, the wide world of sort of solution level or project level application development or architecture really kind of looks like this box. You wrote some C++, you wrote some Java, potentially you wrote some Python. There were certainly multiple files in a lot of cases, but in almost all of those cases, there was a single executable, and that single executable had a job, and it performed that job, and you were kind of done. There are certainly applications that fit in this bucket in the wide world of software engineering. If you think about something like Snagit, or if you think about something like Notepad++, that is an executable that does a job and people are appreciative of that job, and that's kind of where the buck stops. That is not necessarily what all applications look like, and increasingly this sort of concept of a single executable application is becoming more and more and more pushed aside in favor of what's called a multi-tiered approach. So at its most basic, you have two sides of things, and people have already started kind of referring to people in their group as members of the front end or the back end team. Typically front end development is all around UI, it's around client side business logic, that kind of stuff, validation, data collection, data reporting, so on and so forth. Backend development is typically server-side, so it is persistence, putting something into a MongoDB database or into SQL Alchemy or into Microsoft SQL, and the processes that are required to take things from the front end and put it into that repository, and then taking things from that repository and actually providing it to the front end so that it can be displayed in some kind of meaningful way. So front end and back end, these are terms that get thrown around all over the place. If you are a quote full stack developer, that means that you are in charge of all of this stuff. So you can fix bugs, you can implement features that run the gambit of I have a button that doesn't necessarily work when I click it, all the way to I saved a piece of data and the piece of data doesn't make sense when I read it back into the form. So this is the kind of natural split when you start talking about something like server, client-server development versus just a kind of application that exists on somebody's desktop. So if you kind of drill down and you keep drilling down, you can split these things even further and further. So one of the things that happens to software engineers is that software engineers ultimately get given a whole bunch of different jobs. So we've talked previously about software engineers being therapists in some cases, and software engineers being all sorts of stuff. In a lot of cases, software engineers are tasked with being designers. So there are people who have to take design and then like actually create that in HTML. So this is specifically talking about something like a view that a person would actually use and click and kind of experience and react with. There are also things on a client machine that actually perform business logic. So things like button click handlers and things like the ability to enter data and have that data validated prior to being shipped over to a server. And if you're looking at the backend team, the backend team also has a whole bunch of business logic that could potentially happen prior to pushing something into the database. And so if it doesn't meet some criteria, you could get some nasty gram error back from the server to your client machine saying that you didn't do something, you didn't fill out a date appropriately or whatever. And you also have people who are focused on the persistence model. And so what you kind of tend to see is as the software team that you're working on increases in size, you tend to have people who specialize in each of these buckets while still retaining the kind of full stack experience. You could certainly fix business logic issues on the client side, but if you are better at HTML and there are 12 people on your team, there's probably a person who's very, very good at JavaScript or very, very good at whatever language you're using on the client side that will fix this issue and leave you to your HTML. Likewise, larger teams tend to have people who are very good kind of DBA type people who work primarily with persistence, while they also have kind of backend developers who deal with the actual server implementation. So that's the C# Java kind of stuff that happens behind the scenes. So throwing kind of all the vocational stuff away for a minute, all of this typically happens on the client side of things. So this is happening on somebody's desktop, it's happening on somebody's laptop, it's happening in a browser or on a phone or on some kind of controller that is on the wheel of your car. It is happening far away, potentially from the persistence and from the server-side business logic. That is happening on a server, God knows where. So this could be hosted, it could be an on-premise server in another country, and basically the distributed nature of this architectural design is kind of increasing in popularity largely because this server-side component can now be hosted in the cloud quite cheaply, and for the money, what you're really getting is you're getting all the redundancy and you're getting all the performance, you're getting all of the scalability of a very large company like AWS or Microsoft or name your favorite one. And so you don't necessarily have to deal with the infrastructure. What you really have to deal with is the code that lives inside of the infrastructure. And that is a much better place to be from a risk perspective if you are solely a software company. You're not necessarily like an IT shop. So in theory, right, you don't necessarily only have a workstation and a server. Potentially, you could have a workstation and you could have a web server that is hosted in Azure or AWS, and you could have a database server that is also hosted in Azure or AWS, and these could be drastically different servers. And it turns out that the way that most of the cloud hosting services are set up now, this is not just a server. This is hundreds or potentially thousands of servers that dedicate some percentage of their resources to act like a single server. So this is really a server farm, and this database server could actually be a database server farm. And so the distribution increases, right? Like you're not just going from a client to a from a workstation to a server. You're going from a workstation to a server, and then from a server to another server, and then all the way back to the client's machine. So this kind of back and forth and back and forth and back and forth. If you think back to our kind of architectural case study that we were doing, we were trying to build or propose a design for a PNC application. If you're using something on the older side, so you're using something like SOAP, these communication points can be very, very painful. So if you're trying to pull tons of data over the wire from the app server to the workstation, or from the database server to the app server, you could wait a really long time. And so if this was 2000 or 2005, this kind of architecture is kind of risky, because if you don't have very, very optimized code, you don't have a very good plan for performance, you could generate a distributed application that had really bad performance and nobody would actually want to use it. These days, because most of the stuff is hosted, and it is hosted by very large companies that have the ability to distribute their physical resources, it is very likely that you're able to get very fast access to those cloud resources. And as a developer or as a user of the system, you don't actually even really know if these are on different servers, or if they're on the same server, or if it's on 78 servers or 2 servers or 15 servers, and you don't actually care. The only thing that you care about is that the code is doing what you expect it to do, and it will continue to do what you expect it to do until some failure. And if you're hosted, that failure is kind of out of your control. It's somebody else's problem. So going back from the kind of technical reasons why distributed application development is becoming popular to the economic reason why distributed application development is becoming more popular. If you think about the services as being this hosted black box, I'm going to call these commodified services. You can think of this as Hulu, this could be Netflix, this could be Google Translation Services, it could be the Microsoft Graph, whatever you want it to be. Basically what people have is they have these client machines. And these commodified services, they are communicating across very well-known protocols. So these protocols are HTTPS, they're TCP/IP, they're using SSL, and there's no voodoo between these machines. They're speaking very well-known sort of technical languages, and it doesn't actually matter what these clients are. So while you could have one person with a desktop application talking to a commodified service, trying to send a whole bunch of files to be translated by Google Translation Services, you could just as well have a web application on a different machine using these same commodified services. You could have an Android application, an iOS application, an IoT application, and all of these different things in all of these different places on Earth are calling into the same black box. So if you take a step back to last week and we talk about software licensing and we talk about getting the most bang for your buck in terms of being a software engineering firm and being able to resell value, what these commodified services do is they allow you to have a pay-to-use model where you charge per access, or you charge per month, or you charge per some unit. And the more clients that you can manage, the larger market you can actually sell into. So instead of having this very tightly coupled kind of idea where you have an iOS application and you have an Android application, you have a desktop application, you have all these different application stacks in order to maintain, in order to sell to larger groups of people, what you can have is increasingly stupid clients. So you can have an iOS application, an Android application, a web application, a desktop application, and all of this code is as stupid as possible. It's basically just HTML fronts, or it's just some UI. The client-side business logic is the absolute minimum, and all of the kind of value-add content, so all the value-add business logic gets pushed into this commodified service, and you have way less code to maintain, and you're reusing way more compiled code in order to provide services to a larger group of people, and you are minimizing the risk of inserting bugs as you improve or expand these services, because as you improve the actual service, You don't necessarily have to make a bunch of modifications to the client. And if you do have to make modifications to the client code remains very small. So if you add brand new features to the commodified service, you can choose which clients consume that new functionality. And if you want all of them to consume the functionality, that's kind of a worst case scenario in terms of expansion. But all you have to do is go and modify a very small piece of code, and you're fairly certain that when you modify the IoT application, you're not going to crash the iOS application, and when you modify the Android application, you're not going to blow up the web application. And what that does is insulates you from breaking changes on multiple platforms. So while even in the absolute worst case scenario, you could break the web application client, somebody will probably just get mad at you and whip out their Android and start using the service, and then now everybody's happy again. So distribution helps a lot. It helps you sell into a larger group of people. It helps you stay relevant. It also helps you provide services at a much lower risk of either breaking changes or having to rewrite a bunch of client-side code when dang near everything can be done on the server now and then shipped over to a dumb client, like dumb client machine. So you can kind of thought experiment around companies that have begun making this transition. And the absolute number one that should stick out in your mind is Microsoft. So if you think way back in the day, you would go and you would get a CD. The CD would give you Microsoft Office. It would give you Word and Excel and all sorts of whatever. And these were standalone applications. They go all the way back to the very first slide. We had one big box. Now, what is happening is everything is being migrated to Office 365. You certainly do have client style code that runs in a browser, and you can do Microsoft Word edits and creation of documents. You can do all sorts of stuff. But the heavy hitting stuff, so cross-document searching, OneDrive syncing across multiple machines, disaster recovery, integration between client-side apps so that you can copy and paste an Excel table into Word, or you can perform Excel lookups in a non-Excel application. All of that kind of stuff is happening through commodified services that have nothing at all to do with the original client application that you bought 10 or 15 years ago. So if you think about commodified services and how they impact you even as a student. So if you're a student, that means that you have access to portal.office.com, which means you have a license, which means somebody is paying for a license for you to have access to things like PowerPoint. You also have access to OneDrive, which means that someone is paying Microsoft in order to A, generate a document, and then B, store that document. On the horizon, there's a thing called Microsoft Graph, and Microsoft Graph will allow you to search and integrate data from various different types of documents. It's a sort of very powerful tool, and that will almost certainly also come with license fees. So these kind of headless, meaning they could have whatever head they want, microservices allow Microsoft to bill you essentially microtransactions for every different type of thing you want to do with your data. So if you want to get down to it, they could charge you for Word and PowerPoint and Excel and whatever, and they could also charge you for saving that data to the cloud. They could also charge you for storing that data in the cloud. Then they could turn around and charge you for searching that data in the cloud, or securing that data in the cloud, or sharing that data in the cloud. And each of these additional pieces of functionality are really just commodified services that they can bake to their heart's content, and then they can drum up a bunch of interest and then force you to buy them in some ways. So that is a huge reason why this kind of distributed commodified service concept is becoming so popular. And you can kind of see it makes a lot of sense. So what this is a very high level kind of overview of what I would perceive to be exactly the opposite of the architecture that you might have seen in the degree program so far. So you're probably very aware of executables and kind of computer applications. You're probably less tuned in to this kind of multi-tier distributed architecture. And these micro headless services, so again, microservices for the smallest unit of commodification possible, and headless for supporting as many different clients as possible, are becoming extremely popular, and it is good to know about them before trying to go out into industry and kind of seeing these words for the first time, or trying to think about these ways of dealing with software for the first time. There will be 2 more videos in this module. The first one is I'm doing next, which will be about solid principles. So many of the solid principles you will have already heard before in your life. Many of them we already covered in the implementation or in the architecture slides, but we're going to kind of wrap them all together in this sort of ideology that kind of helps you stay grounded in good application design. And then in the last video, we'll spend a little bit of time talking about very common coding patterns and why those common coding patterns are good from a software engineering perspective, and how they maximize your ability to maintain software going forward, and they minimize your risk of introducing bugs as you kind of maintain and evolve the code over time. So thank you very much for tuning in to this video, and I will see you in the next one.